Hi everyone, so today we're gonna go over this problem which is similar to a problem that you have on the project. So the problem says that for every robbery on the north side of a Blotterville, police are able to identify 6 suspects, and for every robbery on the south side, police are able to identify 3 suspects. There are at least 30 suspects in custody. So we have to use to represent the number of robberies on the north side and represent the number of robberies on the south side. We have to write the inequality. So to write the inequality, what we're going to do, we have 3 suspects on the south side and 6 suspects on the north side. So what I'm gonna write 6 times n. I'm gonna use n for the north side, and I'm gonna use south s for the south side. So I have plus 3s, and it says there are at least 30 suspects. So that will be greater than or equal to 30. Now you can use x as well, so you can say 6 times x plus 3 times y is greater than or equal to 30. So, x would be the suspects from the north side. And y will be from the south side. So, if I want to graph this, what we can do, so if I have 6x plus 3y is greater than or equal to 30, we can put it in a slope-intercept form. So we're going to have to solve for y, because I want to look like this. Y is equal to mx plus b. So let's go ahead and subtract 6x from each side. We're going to end up with 3y. This is going to cancel out. It's greater than or equal to negative 6x plus 30. So if I go from the bottom up, I have negative 6x plus, we have a plus here which you don't see it. And last we divide by 3. On each side. So if I divide by 3, we're gonna end up with y is greater than or equal to negative 2x plus 10. So the slope is going to be negative 2 over 1, and my y-intercept is going to be 10. So if I graph this, so 1, 2, okay, so let's say this would be 10 right here. So that'll be my y-intercept. I'm gonna go down 2 units and 1 over. This tells you down, and this would be left. I'm sorry, right. 1 unit. So down 1 unit and 1 to the right. So the graph is gonna look like this. This here is gonna be a solid line. Solid line. Because I have greater than or equal to. If I have a solid line, that indicates that all the points from this line is a solution to this inequality. Next, we have to decide which part I have to shade. So, if it's greater than, you shade above the line. So I will have to shade this part right here. So if I pick any points from here, it's going to be a solution to my inequality. So if I pick any point from this shaded region right here, a point will be, I'm thinking 5 and 10 will be a solution. Now we can check. So let's test the point. Let's test the point 5 and 10. So if I test 5 and 10, we have 10 is this greater than or equal to negative 2 times 5 plus 10. So that's gonna give you 10. We gotta put a question mark here. 10 is greater than or equal to 0. This will be a true statement. Okay. Another point that will be a solution will be 4 and 9. So I'm going to have 9. It is greater than or equal to negative 2 times 4 plus 10. Well, I'm going to have here, that's going to give you negative 8 plus 10. That's going to give you a positive 2. So we're going to have 9 is greater than or equal to 2. That's a true statement as well. So any point that lies under the shaded region is going to be a solution to my inequality. If I pick a point from here, let's see, if I pick this point here, it's not going to be a solution to this inequality. If I pick the point 1, 1, so let's test another point. So if I test 1, 1, I'm going to have 1 is greater than or equal to negative 2 times 1 plus 10. Let's put a question mark here. So I have 1, is this greater than or equal to, that becomes an 8. So this is a false statement. As you can see, that any point from this part of the graph that's below the line is not going to be a solution. Let's move on to the next problem. The robbery rate on the west side is more than 5 times higher than the robbery rate on the east side. We have to represent the robberies, we have to write an inequality that compares the robbery rates. So it says the robbery on the west side is more than 5 times. So we can write an equation as well. So we can do it this way. We can do y is greater than 5x. That's one way to represent the inequality. If I want to graph this, so this one is going to be easier to graph because we have the slope, and it'll be 5 over 1. I'm going to go up 5 units and write 1 unit. My y-intercept is going to be 0 because I have no number after the x term. So the graph will look like this. So I got 1, 2, 2. So my y-intercept is 0. I'm going to start at 0. I'm going to go up 5 units and 1 over, and I'm going to end here somewhere. Now this one is going to be a dotted line. So that will be a dotted line. So is it, this one is going to be a dotted or a dashed line? Dot line or a dashed line, whatever you want to call it, because I have greater than. So if you have a greater than or less than, you're going to have a dot line or dash line. This indicates that the point that's on the line is not a solution. So to decide which part I have to shade, I have to test a point. I have to test a point from each region. I got 2 regions here. So let's go ahead and test. You know what? I'm going to test this point here, which is 2, 2. If I test 2, 2, let's go ahead and plug it in. So I have 2. Is this greater than 5 times 2? So let's put a question mark. Is 2 greater than 10? That's a false statement. So if I pick any point from this region right here, it's not going to be a solution. Let's go ahead and test the point from this part right here. So I have a negative 1 and positive 1. So I'm going to pick a point right here. So let's pick negative 1 and 1, which is right here. So if I test negative 1 and 1, I'm going to plug it in. So I have a 1 because my y is 1. This is my x, this is my y. I have 1. Is this greater than 5 times negative 1? Because my x is negative 1, so let's put a question mark here. I got 1 is greater than negative 5. So this is going to be a true statement. Therefore, I have to shade this part right here. So any point that I pick from this shaded region is going to be a solution to my inequality. Notice on this one here we have only one information. So that's why it's better to write the equation as y is greater than 5x. On the previous one, we're given more information, so we wrote the inequality in standard form.